So, good afternoon and welcome to the webinar Mining Space Exploration with Remote Sensing, Prospective and Future Application. Today, as we appreciate the collaboration with ESA and NASA, and we're very gratitude to talk about this team. And so we are we are host to ESA and NASA, and we are talking about the future perspective and the starting collaboration in mining space projects. So the principal focus of webinar are the 6 points. The webinar is focused on a brief of history of mining spacing exploration, lunar and Mars explorations, the states of art and the actual projects, remote sensing application, explore other planets for rail lens, the future exploration project that we are just involved with other partners like meteors and comets for FA and magnesium, and also for other materials. Collaboration with ESA and NASA for processing remote sensing data, GIS and geological mapping, analysis samples from different missions, and other else, and also the perspective for investors and perspective for future application is the sixth base point of webinar. So a short brief of history of mining space. The mining space starting in about 40 years ago with Magellan mission to explore Venus. And there was a very simple, with low technology mission, and with mission that involves the basic system, the first type of radar and other else. And so it's just for reconstruction topography. Today, and after 20 and 13 years, we have different missions that start the exploration of other planets like Mars and also Mercury and other else. And so we have just a continuous evolution. And so the study of the 20 years ago about the first mission and lens that it approached on the surface of Mars and lunar. It's very important to have the first sample of rocks that can be analyzed, and we are just in continued studies to determine the possibility of new exploration mining. So today, in the project in which are involved, we are principal using new technology about remote sensing application with high using of computer science and high computer science and artificial intelligence. For determine, for example, the capacity and the potential mining in this case. So we are adjusting to involve in this project. So the new project is involved on different types. There is much more application of remote sensing and GIS, and so one of these is, for example, to study and classify the surface of lunar and Mars. And just we have another approach, particular approach with artificial intelligence, for example, to the classification of meteorite, to determine with the infrared and other else bands of remote sensing, the carbon dioxide location, and the potential of the surface of this asteroid object in space. So a new project is involving especially remote sensing to explore metals on asteroids and explore especially rare lands on other planets. So why rare lands? We know, all people, we know the question about the mining problem on Earth in this period and future period. Instead, the increase of particular about the request of lithium, for example, but also for other mining materials. Remote sensing application for explore planet for rare lands. So we have a typical scale of different bands of remote sensing satellite that we are using. For example, coastal, blue, green, and yellow. And so generally we use the infrared. Especially in the planet where there is a difficult to go through the atmosphere, and so we use this technique. So especially for Mars, we just using the near infrared and the scale color. So explore with remote sensing use generally combine two passive sensors. For the part of create imaging that we are just analyzing from geologists and geospecialists that analyze the image to find the geomorphological form and also the evolution of the surface. And we have also the radar and radiometric mapping to determine the possibility of quantity of minerals in surface. So we see just a focusing for people that we are not all days involved in this kind of projects about rare lands. Today, rare lands in Earth planet, in our planet, we are located in different parts. So we have a small map that represented the real lands on Earth. Real Earth are particularly combined for mineral that are essential for electronics and other components. Principal components of lantanio, cerio, nemedio, holmio, erbio, thullio, and lutecio. So we are a rare lands that very difficult to find and on Earth planet, and so we have a good prospection to find that in other planets, especially on Mars and other else. Mining space exploration goes on, and today the collaboration with ESA have just make the first result from analyzing new image from a mining surface that we have just studied, for example, a specific part of lunar surface with the impact criteria. And so in this part we have a good evidence for possibility of effect of this impact for example, like mineralization and other effects. So recent studies show a very high potential mining resource in Moon crater about, for example, kaolin mineral, mined derivative from basalt crystal and other process. The principal derivative application is on new civilization, probably new civilization construction. So in next 45 years in future. So about the study on Mars that we are involved with collaboration with NASA. And so the Mars Mining future project represents a very high and qualified and difficult challenges because they start about 20 years ago with mission like ExoMars to recent NASA mission about the last year, and that are focused to determine the geological evolution of planet and the geological settings to establish the past presence of primitive forms of life. Today, the collaboration with NASA and ESA is focused to determine the prospective possibility to make mining concrete within the next 20 years. The surface of Mars is rich in material based on bauxite, tantalum, regolith, and so all minerals that in the past is involved in the alteration process by, for example, by the presence of water in some region of Mars. So it's probably altered by the presence of water. And so, but the activity of the exploration at TD is only concentrated and focused on the consulting by NASA, in this case for Mars mining, and in consulting for ESA about to analyze the image of lunar to determine geological settings, to determine the potential extraction of basalt derivation products. So we are not involved in space, in direct space mission. But we are very partners supported these projects and future projects to be continuous analyze the data that becomes from satellite images. And so we have one just that we have received 2 days ago about, for example, the mineralization of Jezero crater by ESA. We have made some analysis that show the presence of different relevant minerals that like carbonated and ferromagnesic phyllosilicated. And so we are really interested in this developing of these projects and this collaboration. So because we have a high potential business developing for the future in the next 20 years. So the next project that we are working is establish quantitative of ferrium, magnesium and nickel and non-classified elements. So one of the best challenges and in this next future is also to study the composition of asteroid. New approach to study composition to comets and meteorites is giving important results on what they will be in the next 20 years. The possibility of, for example, of capture of this object in order to obtain iron of nickel, cobalt and materials that is still unclassified on Earth. We will use old example captured by, for example, today in our laboratory, we are studying an old sample that captured by Rosetta mission that is bring sample of meteorite and to analyze in microscope the quantitative of ferrium magnesium components. And so we are really interested and enthusiastic by the first results of this analysis. So we open to go on study and to reinforce the collaboration with ESA and NASA. So next project is very challenging because the difficult in next 20 years is try to capture an asteroid to make a complete analysis or to use that for mining scope. Actually, we are thinking that in one mass of asteroid of about 100 kilos that be contained in up about 20 kilos iron magnesium. The restant part is 95% of meteorites contain iron, nickel. This kind of minerals are still interesting for various type of industries like aerospace or machine space and other else. So the contribution of to this research and with the partners, also with the university and other else, bring to do very well and very interesting. So collaboration with NASA and ESA goes on, and we are still processing data by remote sensing data and GIS for geological mapping, analyze, for example, the first samples of rock of old mission to determine a very precise quantity of some elements like ferrium, nickel, and not classified element, because we are interesting to do in a part of this job, part of this collaboration. So today the classification will proceed with very intensive using of machine learning and computer science to do with deep learning tools that permitted a very precise and constant analysis of data that became from remote sensing, data processing, and GIS mapping. So today, all days, we produce an update from the data that became from the acquisition of ESA and NASA. And the perspective for the collaboration is very good, because today we are in a partnership with these two, and the measure we are expecting big investments about the government and also private corporate like Amazon, SpaceX, and other minority partners. We think that the future space mining will be a very part of the business, and also can be represented a solution for the necessity of planet to have a constant part, to have lithium, to have, for example, all materials that we need for construction, for activities like aerospace and other else. So investors and prospective a big plan of investment, we attend in the next 20 years very high investors, so about this kind, and we think we are involved geologists, project engineering, and geomatician. So the exploration project goes on, and we start now for about an investor between 20-13 years. So there will be a very big project that we are involved with ESA and NASA. It's very complex project because we are international partner, we are governments. And also we have to understand that is different to terrestrial mining, because terrestrial mining also in perspective of return of investment is too short. Generally, terrestrial mining have a time of return in 10 years. Instead of space mining that with actual technology have a time of return in 10 years. So we have to focus the clear area of investing, and so after remote sensing, establish target, sending a mission to have a simple drilling target, After we can choose the area of investment. So this is a brief of what we are doing in collaboration with two space agencies, and we are very pleased and we are very honored that we be hosted of two space agencies and to goes on collaboration. Thank you so much, and for only question or for we can write here.